The aluminum handrails and the fixed pier walkways should be bonded. The National Electrical Code, or NEC, requires bonding of all conductive materials within the grounding path, including equipment, conduit, and cable armor to ensure electrical safety. The aluminum swim ladder should also be bonded. The NEC requires that all metal structures within 20 feet of any waterfront be bonded together to provide a continuous path for electrical currents to the grounding system. The NEC requires a minimum wire size of American wire gauge number 8 copper or American wire gauge number 6 aluminum for bonding conductive objects in waterfront locations. To install the handrails, install a bonding jumper wire between each handrail section and the grounding system at the electrical panel. For the swim ladder, run a bonding wire from the swim ladder to the grounding system at the electrical panel. Make all electrical connections using listed connectors and ground clamps. Avoid concealing bonding wires within walls or posts where they cannot be easily inspected or repaired. There are additional considerations. The grounding system for the floating dock should be designed by a qualified electrician to meet the NEC requirements for bonding in waterfront locations. If the fixed pier walkways are not wired, consider installing a grounding rod or other suitable grounding electrode to provide path to ground for the bonding wires. Regularly inspect and maintain all bonding connections to ensure they are secure and free of corrosion. Bonding is a critical safety measure in electrical systems, especially in waterfront environments where the risk of electrical shock is higher. The National Electrical Code provides specific guidelines for bonding conductive materials to create a low impedance path for fault currents, which helps to quickly trip over current protection devices and prevent electrical hazards. In the context of aluminum handrails and swim ladders on docks, bonding serves to equalize the electrical potential between these metal structures and the grounding system. This ensures that if a fault occurs, such as a live wire coming into contact with the handrail or ladder, the resultant current will flow safely back to the source, tripping a breaker or fuse and preventing a dangerous voltage from appearing on the metal surfaces. Firstly, the handrails, typically constructed of aluminum pipes, present a potential shock hazard if they become energized due to a fault. Because these handrails are often interconnected and accessible to people, it is essential to bond each section to the grounding system. The bonding jumper wire should be securely connected to each handrail section and to the main grounding system, usually located at the electrical pile. This ensures that all sections of the handrail are at the same electrical potential, minimizing the risk of shock. Secondly, the swim ladder, being a metallic structure in close proximity to the water, also requires bonding. The NEC mandates that all metal structures within 20 feet of the waterfront be bonded together. This is because water is a conductive medium, and any voltage potential between the ladder and the water could create a shock hazard for swimmers. The bonding wire should be run from the swim ladder to the grounding system, ensuring a continuous and reliable path for fault currents. Now consider the selection of the appropriate bonding wire size. The NEC specifies a minimum wire size of American wire gauge number 8 copper or American wire gauge number 6 aluminum for bonding conductive objects in waterfront locations. This requirement is based on the ampacity of the wire, which must be sufficient to safely carry the expected fault current. Using a smaller wire size could result in the wire overheating and potentially failing, compromising the effectiveness of the bonding system. When installing the bonding wires, it is crucial to use listed connectors and ground clamps. These connectors are designed to provide a secure and reliable electrical connection that will withstand the harsh conditions of a waterfront environment. They are typically made of corrosion-resistant materials and are specifically designed for use with the type of metal being bonded, such as aluminum or copper. Avoid using wire nuts or other unlisted connectors, as they may not provide a reliable connection and could lead to corrosion and eventual failure of the bonding system. Another important consideration is the visibility and accessibility of the bonding wires. The NEC recommends avoiding concealing bonding wires within walls or posts where they cannot be easily inspected or repaired. This is because bonding connections can corrode or become damaged over time, and regular inspection is necessary to ensure the integrity of the bonding system. By keeping the bonding wires visible, It is easier to identify any problems and make necessary repairs. Also, the grounding system for floating docks should be designed by a qualified electrician. Floating docks are subject to movement and changes in water level, which can put stress on the electrical connections. A qualified electrician will be able to design a grounding system that is robust and reliable, taking into account the specific conditions of the waterfront location. If the fixed pier walkways are not already wired, consider installing a grounding rod or other suitable grounding electrode to provide a path to ground for the bonding wires. This is particularly important if the walkways are located some distance from the main electrical panel. A grounding electrode will help to ensure that the bonding system is effective in providing a low impedance path for fault currents. Regular inspection and maintenance of the bonding connections are essential to ensure they remain secure and free of corrosion. Waterfront environments are particularly harsh, with exposure to salt water, moisture, and extreme temperatures. These conditions can accelerate corrosion of the bonding connections, which can compromise their effectiveness. Inspecting the connections regularly and cleaning or replacing them as necessary will help to maintain the integrity of the bonding system and ensure electrical safety. In summary, bonding aluminum handrails and swim ladders on docks is a critical safety measure that helps to prevent electrical shock hazards. By following the NEC guidelines and using appropriate materials and installation techniques, it is possible to create a safe and reliable bonding system that will protect people from electrical dangers in waterfront environments. It is also a good idea to consult with a qualified electrician to ensure that the bonding system is properly designed and installed, taking into account the specific conditions of the waterfront location. The importance of bonding in electrical systems cannot be overstated, especially in environments where the risk of electrical shock is high, such as waterfront locations. The NEC provides comprehensive guidelines for bonding, and compliance with these guidelines is essential to ensure electrical safety. By understanding the principles of bonding and following the recommended practices, it is possible to create a safe and reliable electrical system that will protect people from electrical hazards. Let's further elaborate on the practical aspects of bonding aluminum handrails and swim ladders on docks, incorporating additional details and considerations for a comprehensive understanding. Firstly, understanding the scope of bonding requirements is essential. The NEC mandates bonding of all conductive materials within 20 feet of any waterfront. This includes not only handrails and swim ladders but also any other metal structures such as fences, gates, and even metal parts of the dock structure itself. The intent is to create an equipotential plane, minimizing the voltage differences between conductive objects and reducing the risk of electric shock. Secondly, when selecting bonding conductors, consider the environmental factors. Waterfront environments are often corrosive due to saltwater exposure. Therefore, use corrosion-resistant conductors such as copper or aluminum with appropriate coatings to ensure longevity and reliability. The NEC specifies a minimum size of American wire gauge number 8 copper or American wire gauge number 6 aluminum, but in some cases, larger conductors may be required based on the fault current calculations. Thirdly, proper connection techniques are crucial. Use listed connectors and ground clamps specifically designed for bonding applications. These connectors should be made of compatible metals to prevent galvanic corrosion. Ensure that all connections are clean and free of corrosion before making the connection. Apply a corrosion inhibitor to the connection after it is made to further protect against corrosion. Fourthly, consider the method of attachment to the handrails and swim ladders. For handrails, bonding jumpers should be attached to each section of the handrail, ensuring electrical continuity throughout the entire system. Use appropriate bonding clamps or lugs that are securely fastened to the handrail. For swim ladders, the bonding conductors should be attached to a solid, non-removable part of the ladder, such as a frame member. Avoid attaching to moving parts or components that could be easily removed. Fifthly, grounding electrodes play a critical role in the overall bonding system. If the fixed pier walkways are not already wired, install a grounding electrode system consisting of one or more grounding rods driven into the earth. The grounding electrode system should be connected to the main grounding busbar in the electrical panel, providing a path for fault currents to return to the source. Sixthly, the location of the electrical panel is important. The electrical panel should be located in a dry, protected area away from direct exposure to water. The panel should be properly grounded and bonded according to the NEC requirements. All bonding conductors from the handrails, swim ladders, and other metal structures should be connected to the grounding busbar in the electrical panel. Seventhly, regular inspection and maintenance are essential for a long-lasting bonding system. Schedule regular inspections to check for corrosion, loose connections, or damaged conductors. Clean any corroded connections and replace any damaged components. Rotate all connections to ensure they are secure. Eighthly, documentation and labeling are important for future maintenance. Keep a record of all bonding connections, including the location, conductor size, and type of connector used. Label each bonding connection with a weatherproof tag indicating its purpose and the date of installation. This will help future electricians or maintenance personnel to understand the system and perform necessary repairs or upgrades. Ninthly, consider surge protection. Install surge protection devices at the electrical panel to protect against voltage surges caused by lightning or other electrical disturbances. Surge protection devices can help to prevent damage to electrical equipment and reduce the risk of electrical shock. Finally, seek professional guidance. Consult with a qualified electrician experienced in waterfront electrical systems to ensure that the bonding system is properly designed and installed according to the NEC requirements and local codes. An electrician can perform a thorough assessment of the site and provide recommendations for the best bonding solutions. Here are more important aspects to consider for bonding aluminum handrails and swim ladders on docks. Firstly, addressing dissimilar metals is crucial. When bonding aluminum to other metals, such as steel or copper, galvanic corrosion can occur. This is because aluminum is more anodic than these metals, meaning it will corrode preferentially when in contact with them in the presence of an electrolyte such as salt water. To prevent galvanic corrosion, use connectors and hardware made of compatible metals such as aluminum or stainless steel. Alternatively, you can use insulating materials such as nylon washers or sleeves to separate the dissimilar metals. Secondly, considering the effects of stray current corrosion is important. Stray currents are unintended electrical currents that flow through the earth or water, often originating from nearby electrical systems or equipment. These currents can cause accelerated corrosion of buried or submerged metal structures, including aluminum handrails and swim ladders. To mitigate stray current corrosion, ensure that the electrical system is properly grounded and bonded, and that any potential sources of stray currents are identified and corrected. Thirdly, understanding the role of cathodic protection is beneficial. Cathodic protection is a technique used to prevent corrosion of metal structures by making them the cathode of an electrochemical cell. This can be achieved by using sacrificial anodes, which are made of a more anodic metal such as zinc or magnesium that corrodes preferentially, protecting the aluminum structure. Cathodic protection can be an effective way to extend the life of aluminum handrails and swim ladders in saltwater environments. Fourthly, consider the impact of marine growth on bonding connections. Marine growth, such as barnacles and algae, can accumulate on bonding connections, creating a barrier that reduces their effectiveness. Regularly clean bonding connections to remove marine growth and ensure good electrical contact. Fifthly, addressing the specific requirements for floating docks is important. Floating docks are subject to movement and flexing, which can put stress on bonding connections. Use flexible bonding conductors and connectors that are designed to withstand these movements. Also, ensure that the bonding system is properly grounded to the shore-based electrical system. Sixthly, consider the use of underwater grounding plates. In some cases, it may be necessary to install underwater grounding plates to provide a low impedance path for fault currents in the water. These plates should be made of a corrosion-resistant material such as copper or stainless steel and should be properly bonded to the grounding system. Seventhly, the importance of proper wire routing and support. When routing bonding conductors, avoid sharp bends or kinks that could damage the insulation or weaken the conductor. Support the conductors properly to prevent them from sagging or rubbing against other objects. Eighthly, labeling and signage can enhance safety. Clearly label all bonding connections and grounding electrodes with weatherproof tags or signs. This will help to identify the purpose of the connections and ensure that they are properly maintained. Ninthly, consider the requirements of the local authorities and codes. In addition to the NEC, local authorities may have specific requirements for bonding and grounding in waterfront environments. Be sure to check with the local authorities and obtain any necessary permits before installing a bonding system. Finally, ongoing education and training are essential. Stay up to date on the latest codes, standards, and best practices for bonding and grounding in waterfront environments. Attend training courses and workshops to enhance your knowledge and skills. By staying informed and continuously improving your knowledge, you can ensure that you are providing the highest level of electrical safety. These considerations, combined with the earlier points, provide a comprehensive framework for understanding and implementing effective bonding solutions for aluminum handrails and swim ladders on docks. Always prioritize safety and consult with qualified professionals to ensure compliance with all applicable codes and standards.